This video is on section 5.4, which is product to sum and sum to product formulas. Here are the objectives. These formulas, basically we are going to go from a product, which is multiplication, to a sum, and then the reverse, a sum to a product. Here is the first set of formulas, and these are the product to sum formulas. And there are 4 of them here. And you can take some time to kind of notice some of the differences, which involve the signs. So go ahead and pause this and kind of analyze these formulas a little bit. All right, let's jump into verifying. So when we look at this, we can see that the left-hand side is more complicated. And if you look at this, this is one of the identities directly from the previous slide. So it is one of the formulas. But the issue is we have to prove it. So what we're going to do is we are going to start with the more complicated side. We're going to start with the left-hand side. And we are going to use the sum and difference formulas from section 5.2. So when we apply the sum and difference formulas, I'm going to apply it here and then here. So we're going to keep the 1/2, and we get the following. So for the first piece, we get sine of u times cosine of v plus cosine of u sine of v. And then we have a plus sign. We'll do the second one, which is the difference. So sine of u cosine of v minus cosine of u sine of v. Okay, well, this cancels out with this, and these are like terms. So we have this 1/2 on the outside. If we have 2 of those, this becomes 2 sine of u cos of v, and the 1/2 and the 2 cancel out, and we are left with sine of u cos of v. And we've just verified the identity. Okay, let's try this. So another type of example other than verifying identities, you'll see something like this. And we can see that this is a product because we have cosine of 8x times sine of 5x. And what we want to do is we want to rewrite this as a sum or difference. So I'm going to let 8x be u and 5x is going to be v. So I want to use the formula cosine of u sine of v. And that formula is 1/2 sine of u plus v minus sine of u minus v. All right, so let's go ahead and use this formula. So cosine of 8x sine of 5x becomes 1/2 sine of u plus v, so in our case 8x plus 5x, minus sine of u minus v, so 8x minus 5x. Now what we'll do is we'll simplify each of the arguments. So we have 1/2 sine of 13x minus sine of 3x. This is my final answer because I do not have like terms. And this is it. Let's try another one. Okay, so here I'm multiplying cosines, and we notice that we have a negative argument here. So you have two choices. You can just proceed with this being u and this being v, or you can rewrite this with a positive argument. Either way is totally fine. I'm just going to proceed and leave this as is. So I'm going to use cosine of u, cosine of v, which is the following formula. 1/2 of cosine of u minus v plus cosine of u plus v. All right, so this is what we'll use. So this becomes 1/2 cosine of u minus v, so in our case 2x minus a negative 5x, plus cosine of u plus v, so 2x plus a negative 5x. Okay, just like the previous problem, we're going to simplify inside the parentheses. So I have 1/2 cosine of, remember a minus a negative becomes plus a positive, so this is 7x, plus cosine of negative 3x. All right, recall that cosine is an even function, so if you have a negative argument, you can rewrite it as positive, and everything is positive. So 1/2 of cosine of 7x plus cosine of 3x. These are not like terms, so this is the final answer. Okay, so this one, we still want to use the formula, but now we're going to find the exact value. In this case, I know I'm able to do this because my arguments of my trig functions are not variables anymore. Now they're actual numbers. So I'm going to let 5 pi over 12 be u and pi over 12 be v. So I'm using the formula for sine u times sine of v. All right, let's just plug that in right now. So this will equal 1/2 of the following, cosine of u minus v, so 5 pi over 12 minus pi over 12, minus cosine of u plus v, 5 pi over 12 plus pi over 12. All right, just like before, we will simplify our arguments to get the following. The first one, 5 pi minus pi is 4 pi over 12, minus cosine of 6 pi over 12. And we'll just continue to simplify this. So we'll have cosine of pi over 3 minus cosine of pi over 2. All right, pi over 3 has the associated ordered pair 1/2 root 3 over 2. Cosine of pi over 2, remember this is pi over 2, which is 0, 1. So when we simplify, cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0, so I end up with 1/2 times 1/2, which is 1/4. So the exact value of this product is 1/4 using the formulas. Let's verify another identity. Now looking at this, both the left-hand side and the right-hand side look pretty messy. Looking at this, you might think, oh, I want to try a sum and difference formula because of this and this. Well, if you try a sum and difference formula like I tried, you will get something really, really messy. You'll have things that are squared, and you don't want that looking at the right-hand side. So it just gets messy. So instead, let's use the following product to sum. So I'm going to start with the left-hand side, and I'm going to let this be u and this be v, which is messy, but it ends up working out. So I'm going to use sine of u cosine of v, that formula. All right, so when I do, the left-hand side becomes 1/2 of sine of u plus v. So when I'm taking u plus v, I'm going to add these two arguments. So x plus y plus x minus y plus sine of u minus v. So x plus y is u minus v is x minus y. Okay, simplifying the arguments, you should see that the y's cancel out here. And when you distribute this minus, you'll find that the x's cancel out here. So the left-hand side becomes 1/2 sine of 2x plus sine of 2y. Well, now you're going to use double angle formulas. And when you do, you'll use it twice, here and here. You get, for this one, 2 sine of x cos of y. I'm sorry, cos of x. They're both x's. Plus, over here, you get 2 sine of y cos of y. Notice these both have a 2 in common, so you can factor that 2 out. And you're left with, sine of x cos of x plus sine of y cos of y. And hopefully you've glanced ahead at the right-hand side. You'll see these cancel out, and you are left with sine of x cos of x plus sine of y cos of y, which is what we wanted to achieve. And there you have it. Now let's look at the reverse, sum to product formulas. Here are the 4 formulas that you will see. And you can go ahead and pause this video and kind of analyze this a little bit. Notice that one of these results in a negative. All right, so let's go ahead and use these to verify this identity. Okay, so I'm going to start with the left-hand side, and I'm going to let this be u and this be v. And here I have a product, and I want to make this product become a sum. And so that's why I am going to use sine of u cos of v. Okay, so I'm going to keep this 2 on the outside, So then I have 2 times 1/2 of sine of u plus v. So this is u, this is v, plus sine of u minus v. This is u, this is v. Okay, the 2 and the 1/2 cancel. And now we need to simplify the arguments. Well, since they have the same denominator, you can write them as a single fraction. So you'll just add or subtract the numerator. So when you do this, you'll end up with 2x over 2 for the first term, and you'll end up with 2y over 2 in the second term. The 2's cancel in both of these, and we are left with sine of x plus sine of y, which is what we wanted to achieve. Okay, so in this example, we're not verifying, but instead we want to take this sum and write it as a product. So we're going to use the formula that we have, and we're going to get the following. So we're taking sine plus sine, so it's the last formula on that sheet, and we get the following: 2 times sine of x plus 3x over 2 times cosine of x minus 3x over 2. Simplifying the arguments, I get 4x over 2 for the first one, and the second one I get negative 2x over 2. Continuing, 2 sine of 2x cosine of negative x. Remember, cosine is an even function, so when you take the negative out of the argument, the function becomes positive. So we have 2 sine of 2x cos of x. This is a product. Even though we have a double angle here, it is perfectly fine to leave this as is. That way we don't end up with a cosine squared. Here's our product, not so bad. Okay, so now we're going to use a sum to product formula to find the exact value. The reason we want to do this is because pi over 12 is not a value on our unit circle. So if we simplify this, this difference here and make it a product, it becomes a lot easier to manage. So let's go ahead and rewrite this using the cosine minus cosine. So this is the only one that has a negative output. So we'll have negative sine of, here we're going to take 13 pi over 12 plus 7 pi over 12, all of this divided by 2, times sine of 13 pi over 12 minus 7 pi over 12, all divided by 2. And then we're just going to do algebra, and we're going to simplify all these arguments. So if you want to pause the video and try to do some of this algebra on your own, that might be wise. So we end up with, when I add the numerators, I get 20 pi over 12 all over 2, and sine of 6 pi over 12 all over 2. Now I don't want fractions within fractions, so I'm going to try to correct this. So we have -2 sine of 20 pi over 12 times a half. That's the same thing as dividing by 2. Same thing over here, 6 pi over 12 times a half. And I can cross simplify. 2 goes into 20 10 times, 2 goes into 6 3 times. So we get -2 sine of, this is 5 pi over 6 times sine of pi over 4. Okay, so we need to evaluate sine of 5 pi over 6 and sine of pi over 4. So hopefully you can identify what those corresponding ordered pairs are and evaluate these trig values. So I have -2 times a half, because sine of 5 pi over 6 is a half, and sine of pi over 4 is √2 over 2. This all reduces to -√2 over 2 for the final answer. And that's it. Let's verify. Okay, so when I am verifying here, the left-hand side has a lot going on, and I can see that it's a sum. Over on the right-hand side, I can see that if I distribute this sign, I will have a product. So I would be able to go from a product to a sum. So I'm going to actually use the right-hand side and use a product to sum formula. So the first thing I'm going to do is I'm going to distribute that sign. So I end up with 2 sine of x cosine of 3x plus sine of x. Okay, so here I have this product. And I'm going to let u be x and v be 3x. I'm going to remember this 2 times the formula now, which is a half, sine of u plus v, so in our case x plus 3x, plus sine of u minus v, so in our case x minus 3x, and then I have to tack on this plus sine of x over here. Okay, just like before, we'll simplify our arguments, and the 2 and the 1/2 cancel. So I have sine of 4x plus sine of -2x plus sine of x. And if you glance ahead and look at the left-hand side, we're getting pretty close. The only thing that we don't have is this middle term. And this middle term is an odd function, so if you have a negative input, the output is also negative, which gets us exactly to where we want to be, which is sine of 4x minus sine of positive 2x plus sine of x. And we are done. Here's the last problem I want to do in this section, and this is another verifying problem. And obviously, the left-hand side is much more complicated than the right-hand side, and we are going to have to plug away at this left-hand side to see what we can come up with. Now, looking at this, each of these can use a sum to product formula. So that's what I'm going to do. I'm going to apply a sum to product formula in the numerator and a sum to product formula in the denominator. So I'm going to start with the left-hand side, and I'm just going to start by rewriting the left-hand side. So when I rewrite the left-hand side, this is what I get. Okay, so starting first with the numerator, applying the sum to product here, I have cosine minus cosine, and this is the only one that has that negative output. I have -2 sine of 4x plus 2x over 2 times sine of 4x minus 2x over 2. Same type of thing in the denominator. I'm going to apply a sum to product formula here, and I'm going to apply the sine minus sine formula. So this is 2 cosine of 2x plus 4x in this case, divided by 2, times sine of 2x minus 4x divided by 2. Okay, now there's some simplifying that can take place. First, these 2's cancel out, but do not neglect that negative sign. So I'll just put that out in front right now. And then I'm going to simplify all of the arguments. And I'm just going to do this in one quick step. So in the numerator, all of this becomes 6x divided by 2, which reduces to 3x, times sine of this becomes 2x divided by 2, which is x, all over cosine of this is 6x divided by 2, which is also 3x. And this is a negative 2x divided by 2, so I'll have sine of negative x. Okay, recall this is an odd function here, so that's going to come out as a negative. So I'm going to take that negative out, and it's actually going to cancel out with this negative in the front. So together, the negative that comes out of the green stuff will cancel this out, and we'll end up with a positive. So we get sine of 3x times sine of x in the numerator, and cosine of 3x times sine of x in the denominator. The sine of x's cancel, and I'm left with sine of 3x over cosine of 3x, which is the same thing as tangent of 3x. Yay, we have just verified our last problem in this section. Yay, a short video.